Welcome to Advanced Learning Tutoring. This is the Physics playlist. Please like this video and subscribe to our channel. Forces, scalar and vector quantities. Scalar quantities have magnitude only, magnitude meaning size. For example, mass, time, temperature and distance. They have measurable sizes, for example, 3 kilograms. Vector quantities have magnitude and an associated direction, for example velocity, which is speed in a given direction, momentum, and forces. Forces act in a particular direction and can be measured with a size, for example 10 newtons. A vector quantity may be represented by an arrow. The length of the arrow represents the magnitude, the size, and the direction of the arrow represents the direction of the vector quantity. Contact and non-contact forces. A force is a push or pull that acts on an object due to the interaction with another object. All forces are either contact forces, where the objects are physically touching, for example friction, air resistance or tension, or non-contact forces, where the objects are physically separated, for example a magnetic attraction, gravitational force, or electrostatic force, which is the force between oppositely charged objects. Gravity. Weight is the force acting on an object due to gravity. So weight or gravity are used interchangeably. Weight is different to mass. Mass is the amount of matter within the object and is measured in kilograms, whereas weight is the downwards force due to gravity measured in newtons. The force of gravity close to the Earth is due to the gravitational field strength around the Earth. The weight of an object depends on the gravitational field strength at the point where the object is. Weight can be measured using a Newton meter. The following equation links weight, mass and gravitational field strength. This is not given on the physics equation sheet and therefore needs to be learnt. Weight equals mass multiplied by gravitational field strength. On Earth, the gravitational field strength is 9.8 newtons per kilogram, meaning for every 1 kilogram of mass of object on Earth, there is a downwards force of 9.8 newtons. A man has a mass of 90 kilograms. Calculate the weight of the man. Weight equals mass times gravitational field strength. So weight equals 9.8 multiplied by 90, equaling 882 newtons. Resultant forces. Resultant force is a number of forces acting on an object that may be replaced by a single force that has the same effect as all the original forces acting together. For example, in a tug-of-war game, if one team are pulling with a force of 30 newtons to the right and the other team are pulling with a force of 10 newtons to the left, the overall resultant force is 20 newtons to the right. Another example, if a car is being towed by a lorry and another car. If the lorry is pulling with a force of 60 newtons to the right and the car is pulling with a force of 30 newtons also to the right, the overall resultant force is 90 newtons to the right, as they are pulling in the same direction. You can use a parallelogram rule to find the resultant force on an object. For example, in our diagram, the single force that has the same effect as the two 300 Newton forces. We can use this to determine the resultant force. Complete the diagram by drawing a parallelogram. As the diagram is drawn to scale, we need to indicate what the scale is, where 1 centimetre represents 100 newtons. So we draw another 2 3cm lines to make a parallelogram. Join up the diagonal and measure the length of the diagonal line. The diagonal line is 5.5 centimetres in length, so we use our scale times by 100 to get our value of 550 newtons. Work done and energy transfer. When a force causes an object to move through a distance, a work is done on the object. So a force does work on an object when the force causes a displacement of the object. The following formula links work done, force and distance. This equation is not given on the physics equation sheet and therefore needs to be learnt. Work done in joules equals force in newtons times distance in metres. An example question. A man pulls a 20 kilogram suitcase along a 10-metre corridor using a horizontal force of 50 newtons. Calculate the work done. First, we must find the weight of the suitcase. A reminder that weight is calculated by doing mass of object multiplied by gravitational field strength. 20 times 9.8 gives 196 newtons, which is the downwards weight of the suitcase. So we have a force of 196 newtons acting downwards. There is a horizontal force of 50 newtons. Therefore, the resultant force is 196 minus 50, which equals 146 newtons. As work done equals force times distance, we can now multiply the resultant force of 146 newtons by the distance of 10 metres, giving a total work done of 1,460 joules. Forces and elasticity, required practical. A force that stretches or compresses a spring does work, and elastic potential energy is stored in the spring. Provided the spring is not inelastically deformed, meaning will not return to its original shape, the work done on the spring and the elastic potential energy stored are equal. This is given by Hooke's law. This is not given on the physics equation sheet and therefore needs to be learnt. The force in newtons equal the spring constant measured in newtons per metre times the extension in metres. Here note that extension in metres may also be given by a compression, again measured in metres. This is because springs can either be stretched or compressed, like in the case of a mattress. Explain how the student could use the equipment of a spring, a pointer and some weights to measure the spring constant of the spring. Change the weight on the end of the spring, measure the extension for each weight, plot a table of results and a graph of the extension on the y-axis against weight on the x-axis. The gradient of the line is 1 over the spring constant, as extension and force are in a directly proportional relationship, as stated by Hooke's law. Moments, levers and gears. The turning effect of a force is called the moment of the force. The moment of a force is calculated by the force multiplied by the perpendicular distance from the pivot. Perpendicular means at 90 degrees or right angles. This equation is not given on the physics equation sheet. The moment of a force, measured in Newton meters, is calculated by force in newtons multiplied by the distance in meters. If an object is balanced, the total clockwise moment about a pivot equals the total anti-clockwise moment about that pivot. An example being, people of two equal downward weights sitting the same distance apart from the central point on a seesaw. A simple lever and a simple gear system can both be used to transmit the rotational effects of forces. Thinking about a spanner and spanners having two different length handles, a shorter length versus a longer length, the pivotal point at the top of the spanner and the distance of that spanner. The greater the distance will provide a greater moment of force. Pressure and pressure differences in fluids. A fluid can either be a liquid or a gas. The pressure in fluids cause a force normal at right angles to any surface. This is given by the formula pressure equals force divided by area. This is not given on the physics equation sheet. The pressure due to a column of liquid can be calculated using the following equation. The pressure in pascals equals the height of the column in meters multiplied by the density of the liquid in kilogram per meter cubed times the gravitational field strength in newtons per kilogram. In a liquid, pressure at a point increases with the height of the column of the liquid above that point and with the density of the liquid. A partially or totally submerged object experiences a greater pressure on the bottom surface than on the top surface, as more molecules are above it. This creates a resultant force upwards, and this force is called upthrust. An example being a scuba diver. The deeper the scuba diver goes, the greater the pressure, as more molecules are above the scuba diver. Atmospheric pressure. The atmosphere is a thin layer, relative to the size of the Earth, of air around the Earth. The atmosphere gets less dense with increasing altitude, as there are fewer particles above. Air molecules colliding with the surface create atmospheric pressure. Explaining why atmospheric pressure decreases with altitude. The number of air molecules above a surface decreases as the height above the surface, above ground level, increases. So as height increases, there is always less air above a surface than there is at a lower height. Therefore, there are fewer collisions of molecules. So atmospheric pressure decreases with an increased height.